Hello and welcome to this session on the rise of Kubernetes as a universal control plane. My name is Janakiram, MSV, and the Principal Analyst at Janakiram and Associates. I'm a CNCF Ambassador, Certified Kubernetes Administrator, and a Certified Kubernetes App Developer. It's my pleasure to be a part of the Crossplane Community Day. The evolution of schedulers. So when we look at how schedulers evolved, it all started from the operating system and has gone to the concept of the scheduler or the control plane used in Kubernetes. Across diverse environments, we encounter schedulers, from application servers to big data clusters to even PaaS like Cloud Foundry. Scheduling plays a very important role in deciding how the fundamental unit of execution is associated with a compute environment or a node where it is actually executed. So in Kubernetes, we have Kube Scheduler, which is the core building block of the control plane. When it comes to influencing Kubernetes scheduler, it is very straightforward and simple. We use labels and selectors to match nodes with pods. We can use annotations to perform advanced scheduling and comprehensive mechanism to influence scheduling. Now, if you really want to take control and force Kubernetes scheduler to do specific things like placing a pod on a node with an SSD or a GPU, we can use node selector at the minimum. And then we can use more advanced concepts such as node affinity, anti-affinity, pod affinity and anti-affinity to completely control the way pods are scheduled. If none of these are useful or helpful to you, you can even write a custom scheduler that will work hand in glove with Kube Scheduler to decide how your unit of execution is going to be scheduled. So Kubernetes Scheduler is the core building block of the control plane that decides and executes the scheduling process. Now, modern infrastructure is all about scheduling the resources the right way. When we deal with cloud platforms, like Azure, AWS or GCP, we are actually dealing with a very sophisticated and advanced scheduler. For example, when you decide what kind of a VM, with how many cores, what is the memory, what is the zone, what is the region, you're actually using a scheduler behind the scenes. And same thing with database instances, same thing with big data, IoT and edge devices, and even serverless and functions. Essentially, when you are hitting the control plane of a cloud and provisioning resources, there is scheduling acting behind the scenes. Now, this is a very important aspect of modern infrastructure. It's almost everywhere. Now, Kubernetes is seamlessly extending this mechanism to multiple other resources which are external to Kubernetes and go beyond containers and pods. So, there are multiple techniques. Of course, this session is not about doing a deep dive on extensibility of Kubernetes, but at a high level, you can extend Kubernetes by using API server aggregation or by writing custom controllers and custom resource definitions. This will act as a bridge between external resource like an IoT hub in Azure or an RDS database engine in AWS with Kubernetes. Now, connecting the dots between custom controllers and custom resources is the operator pattern. Now, that brings in the operator level activity and mechanism to make sure that the entire life cycle of an external resource is managed efficiently. And this can be further taken to the CLI through kubectl extensions. So this combination of writing CRDs, controllers, and operators at the server side and creating extensions for kubectl give us a very powerful set of tools to go beyond dealing with nodes, pods, and containers in Kubernetes. This brings us the ability to integrate external resources seamlessly with Kubernetes. So there are many evidences and examples of how this is being done. Today, when we look at the cloud managed services, the platform vendors and cloud providers are investing heavily in the service operators. Config Connector from Google Cloud, ACK or ACK from AWS, the Azure Service Operators are some of the examples of cloud managed services getting integrated with Kubernetes. And of course, we have Crossplane that is leading the revolution of connecting external resources with Kubernetes and turning Kubernetes into a universal control plane. Then we have virtual machines that are being managed by Kubernetes. Examples include OpenShift virtualization that uses KubeVirt, Migrate for Anthos that lets you deal with the lifecycle of VMs while migrating them into GKE to run as containerized workloads. And more recently, VMware has exposed Kubernetes API on top of vSphere, which will bring us the VM operator. So one kubectl command to deal with clusters, VMs, pods, and even external resources that are running outside of Kubernetes. And then IoT and Edge become the ideal candidate for integrating with Kubernetes control plane. One side we have the deployments at scale and scheduling at scale delivered by Kubernetes, and then we have the huge explosion of IoT devices. And when we bring them together, it becomes a logical combination to manage the IoT devices and edge device deployment at scale. Azure IoT Edge is an example of where Kubernetes is being used to decide the placement of devices in the edge cluster, or even creating digital twins for physical devices and representing them in Azure Cloud. KubeEdge, Virtual Kubelet, which are CNC of projects, are examples of how IoT and edge scenarios can be extended to Kubernetes. And then the database world is building a lot of extensions. For example, Unicorn from Cloudera is bringing Yarn capability to Kubernetes. And DataStax's CAS operator for Cassandra is one such example. Now, this is by no means a comprehensive list. This is just a very high-level list of how the ecosystem is investing in building extensibility and operators and controllers that take Kubernetes beyond typical containerized workloads. Going forward, we are going to see many things coming up. So Kubernetes becomes the front and center of infrastructure as code. The industry has agreed that infrastructure as code is the way to go when it comes to managing and maintaining the desired state of configuration. Now, with Kubernetes becoming the front and center of it, we have much more extensibility and much more control over infrastructure as code. Kubernetes becomes the gateway for provisioning, scheduling, and managing the lifecycle of resources, even if they are not containerized workloads. And Kubernetes API becomes the preferred way for resource orchestration. Thanks to the simplicity and representation of CRUD operations, we can now bring an ERP or a CRM or even a legacy database into the context of Kubernetes and treat it like a resource. Developing CRDs, controllers, and operators will become much more easy and accessible to developers. Combined with GitOps, the concept of Kubernetes as a universal control plane will deliver a lot of power, while GitOps will maintain the declarative mechanism of defining resources in Git, which is the single source of truth. The Kubernetes control plane will translate that to maintain the desired state of configuration. That forms a lethal combination. And finally, kubectl becomes the Swiss Army knife for operators. They'll be able to do many things beyond just controlling the Kubernetes infrastructure or containerized workloads. So we have a lot in store. Very exciting days ahead with the combination of Kubernetes and infrastructure as code. This is the best time to be in the industry and best time to exploit the extensibility of Kubernetes. So thanks for joining my session. Hope you have a great conference ahead. Thank you.